Hello everyone again and welcome. Thank you again for joining us on today's webinar, Benefits of Industrial Ethernet and Coriolis Flow Measurement. My name is Allison Sterling, Marketing Manager at Emerson Micromotion, and I'm pleased to welcome you to our Emerson Flow Expert webinar series. Before we begin today, I'd like to take a moment to acquaint you with our webinar environment. On your screen, you will see a presentation window on the left side, a Q&A chat window in the upper right-hand corner, media player controls, and a resource box with related content that you can view and download during the event. You can resize, move, or minimize any of these windows during the event to fit your viewing preferences. At the bottom of the display, you should have a row of icons that give you added capabilities where you can share this webinar via social channels or request a visit from one of our Flow experts. Throughout our presentation, we encourage you to interact with our speaker by typing in questions and comments using that chat panel. We will be answering questions after the presentation. We are also recording today's session, and we'll make the link to the recording available to you 24-hour post-event via email. And on today's webinar, we are lucky enough to have joining us Jason Leapley. Jason is a product line business manager at Micromotion. He is responsible for maintaining current and development of new electronics and interfaces for flow measurement. He has a degree in mechanical engineering from Colorado School of Mines and is a Colorado native. In his free time, Jason enjoys playing the guitar and spending time with his daughters. Welcome, Jason.
Thank you, Allison. And thank you all for joining. Here's an agenda of what we'll be going through today. We'll start out talking about what is industrial Ethernet and what are the benefits of it, what people are looking to get out of and where the potential is for that. Then we'll move into the benefits of Coriolis measurement as a whole. We'll take some time to talk about some advanced Coriolis capabilities, and then we'll pull it all together talking about some installation and integration options and best practices. So if you're looking to integrate either an industrial Ethernet network or you have one and you're looking to bring some Coriolis meters into it, some tips and tricks and ways to get the best and the most out of your investment. So for the first section, I'd actually like to go ahead and start with a bit of interaction here. We got a poll that we're going to ask the attendees to participate in. So if you see it there, just a question out for you, looking for the attendees to get a feel of the group. How many of you currently use Ethernet networks in your plant or field? So you can go ahead and click the proper response that applies to you. We'll give a minute or so to collect the responses, and then we'll take a look at what the group has said and have some talking points to address as we move forward. Okay, looks like we got about 75% of the participants responded so far. We'll go ahead and move forward in case some people aren't able to respond. Let's see what the results are. So we're looking for, a pretty good distribution here. It looks like some people don't use networks at all, but a good chunk of the attendees on here actually do use them and have them out in the field or in the plant. So that's great. Moving forward in this next section, some of the benefits of the Ethernet networks will be well known to some of you that already use them, but hopefully there's some additional information there. And the ones that are unfamiliar with them or don't use them, hopefully there's some good things to think about and some potential opportunities there for you to make the best of something moving forward. So to start with, we'll just frame it up and talk about what is industrial Ethernet. It seems to be a term that a lot of people are talking about and throwing around these days and can seem to mean a lot of different things. So at the very high level, always turn to our old friend Wikipedia to see what the definition they have. And according to them, industrial Ethernet refers to the use of standard Ethernet protocols with rugged connectors and extended temperature switches in an industrial environment for automation or process control. So in essence, what this really is taking the most of this equipment that's been developed for generally home and commercial networks and the speed and benefits of that, and then adapting it and turning it into something that can add a lot of benefits to a process or a manufacturing environment. So what are the benefits of that? Why is that beneficial? It's quickly growing in popularity due to several reasons. First off, the technology is well suited for the increasing amounts of information and data that is needed to continue to optimize and improve your process operations. Second, the technology is well understood and familiar, and this is a big piece here. People recognize the benefits of Ethernet because they've seen with their experiences at home and in the office what it can bring to them and what it can open up. This also allows an additional source of expertise within an organization, as now company IT departments can actually be utilized for plant network support, looking to understand something that's going on with your network traffic or how to set up some devices. Again, this is providing that is a benefit for you. Otherwise, some people would rather IT not interfere with their process equipment, but it can provide a secondary source of expertise there as well. Third, since infrastructure is generally based on wiring and switches, they're extremely prevalent in other applications. This can actually lead to a significant cost savings for establishing a network. Because these devices have been mass-produced and used so often and so widespread, it really results in a much lower cost or barrier of entry to start up a network or to continue to maintain and expand one. And finally, the communication standards are very established and proven, leading to minimal interoperability challenges or needs for very specialized expertise. At this point, it's worth talking about the distinction between Ethernet, as in the physical network, and the protocols that lay on top of it. So, Ethernet is the physical network in terms of the switches, the wiring, the cabling, but on top of that can exist several different protocols or communications between devices. What we've seen is the initial adoption and where the greatest growth has been recently is using the protocol Ethernet IP, and as a result, a lot of times people interchange the terms using Ethernet IP just to mean in general an Ethernet network. But it's important to realize that there are other protocols and communications that can happen on that same network. There's a couple examples here. Profinet is one that's gaining in popularity based with primarily Siemens type systems, and then there's even a protocol called Modbus TCP, which is essentially Modbus, which many people in the process industry are familiar with, but it's based on the Ethernet physical layer, so it travels on the Ethernet connections, and as a result you get a great increase in speed and ability to transfer information. So a little bit about the speed and the benefits and scalability that you can accomplish with a Ethernet networks. One of the primary reasons you could see some benefits from using an Ethernet or industrial internet network is to remove possible bottlenecks with other types of communications, as well as giving future overhead to be able to grow and expand and move forward into the future years. For example, the benefits of a digital device communication have been known for decades in terms of getting richer process data and diagnostics compared to older methods like a simple analog or frequency signal. However, even typically used serial-based communications like Modbus or field bus-based communications like Profibus are starting to hit their limits in terms of the amount of data that can be transferred. Additionally, more and more devices are implementing onboard logging and data capture, and inherently these current communication networks and protocols are not designed for the ability to do file transfers to get this information off, which is something Ethernet is inherently designed around. To give an example, when you look at the standards for Ethernet connections, most devices these days will generally meet both the 10 base T or the 100 base TX standard, which is basically 10 megabits per second or 100 megabits per second. So when you look at that and you compare to something like the transfer rate or communication speed on a HART or field bus device, you can see not only can the individual devices themselves are now able to respond much quicker on an Ethernet network. From what we've seen, individual response times can actually be 20 times faster, something in that range. The amount of information that can travel on an Ethernet network is vastly improved. The pipeline, if you will, or the highway is much bigger, so to enable you to pass more information back and forth on that one particular network. So putting an industrial Ethernet network in place really removes these bottlenecks and restrictions, but it also gives you room to expand and grow with future needs. For example, you can have multiple protocols and systems. They can all exist and communicate with each other using their own particular language or protocol on the same physical Ethernet network. And on top of that, it still gives you even more overhead for some additional advancements or implementations you might not think of to put on a process network. One example we see more and more is the ability to pass live video. So people are interested in being able to put video feeds on their process line or their manufacturing line and be able to write that back live into a control room or something like that, so they can actually look and see exactly what's going on with their process real time without having to actually go out into the plant and be physically present there looking at the process. So along those lines, Ethernet can also be a good enabler for another topic that a lot of people seem to be talking about these days, which is remote monitoring. So the final potential of this can really be simplified and expanded with the use of an industrial Ethernet network to be able to enable some of these benefits. And as process expertise becomes more and more valuable, this can enable the most of that expertise by allowing subject matter experts access to information from multiple units or even multiple plants in a centralized location, removing the need and hassle from them needing to travel out to the physical installation area of devices and equipment. So being able to utilize expertise in a more productive fashion, plus safety is always number one in everybody's mind. So if you can get information out of devices, particularly if you're looking to do some advanced process analytics, optimize a process, or do some troubleshooting, the more you can do to actually bring that information out into a control room or a safe area versus having somebody have to go out into the plant or the environment or the field and physically interact with the device can be a huge benefit. And additionally, this can actually open up and serve to ease the flow of information to business departments that aren't traditionally involved with the day-to-day process system. As an example, a lot of times they'll have an environmental health and safety group that needs to get some information for reporting purposes, maybe some regulatory compliance or something like that. This can pull that information out and get it directly to those groups and those stakeholders easily without having them have to run through the typical process system, have reports made and filtered and things like that. You can really select and send information to those that may have more traditional, I'd say, business needs versus running the process needs. So this is interesting. We were looking, and there's been a lot of market research, obviously a big topic right now, about this whole trend of the industrial Internet of Things, which is basically taking this concept of interconnected devices, the Internet of Things that's been growing, and people are talking about things like Nest in their home and how devices can talk to each other and update each other. And now people are really starting to focus on, okay, well, what's the potential of that in an industrial manufacturing environment? So they sort of coined this industrial Internet of Things you might see a lot of people talking about, or the IIoT. And looking into it, when you look at the growth of these devices, both historically and into the future, pretty much every research and market analysis points to a very significant growth in the amount of internet-connected devices or connectable devices in the industrial manufacturing environment. For example, most all growth rates are predicting a CAGR of somewhere around 20% or even more over the next 5 years. Another thing that's interesting is this technology has really sort of had its roots and its initial implementation in industries like food and beverage and specialty chemical, sometimes a lot of things dealing with skids and things like that. But it's really starting to expand outside of that into other industries where you might not think of utilizing an Ethernet network. For example, moving out to what we call the field, out of the plant and into the field. One of the interesting things is we recently talked with a major oil and gas producer, and they were extremely proud, I would say justifiably so, by the Ethernet network they had installed and established out at one of their sites. It was really quite extensive, and they're well positioned to be able to utilize that well into the future as they look to gain the most and optimize their production. One final thing to point out is a graph down there at the bottom from a report that I found particularly interesting, which is when you look at the overall growth of internet connectable devices, shows to be growing pretty steadily at a good clip, as you would expect. But the thing to note is the red section there is what would be called industrial devices, and then the blue section would be all the others: computer, consumer, medical, communications, etc. So you can see not only is the overall growth pretty significant or impressive, the mix shift and how fast it's expected industrial devices are going to become a good portion of those overall devices is a pretty interesting and telling sign to me. So with that, let's shift gears for a little bit, and let's talk about the benefits of Coriolis measurement. And then we'll come back and tie that all together and see how the pairing of Coriolis measurement with industrial Ethernet network really is a good fit and enables you to get the most out of what you're looking for your process control and your flow measurement. So do another poll at this point. Let people give a chance to talk about your familiarity with Coriolis meters. So I'd like to go ahead and select an answer there on whether you currently use Coriolis meters for flow measurement. And again, we'll give it a couple seconds, half a minute or so, to let everybody that's able to submit a vote. Okay, looks like we got the majority of responses in. Let's take a look at the results here. All right, pretty good mix as well. Looks like the majority of you are familiar, either use Coriolis measures or Coriolis meters, or are very familiar with them and use them considerably. That's great. Some of you in that group could probably teach me a thing or two about them. For those that have no experience or limited experience, I think this will provide some further information into Coriolis. And for those that use them extensively, hopefully we've got a couple things in here for you as well. Either you didn't know what a Coriolis meter could do or some of the recent advancements in the technology. So to start with, just an overall description of the Coriolis flow measurement technology. At its heart, it's relatively unique as it's a true multi-variable measurement, all coming from a single device. Here you'll see a picture of a typical Coriolis flow meter, and they're well known for providing accurate mass flow measurement. However, they also measure density of the process fluid and have built-in temperature measurement as well. Using the density and temperature measurements, they can calculate and output other variables such as percent concentration, percent solids, so you can use those in applications where you're looking like, for example, sugar content in something, or percent acid concentration as well, directly out of the device. These process variables are available regardless of the direction the material is flowing, so whether they are being used intentionally for bidirectional applications like loading or unloading, or if the flow changes directions unintentionally, the user has the ability and the visibility not only to the flow of the fluid, but can also see how the fluid is behaving or some of its properties. The data that can be output from a Coriolis meter is very rich in process information. Additionally, although at its heart Coriolis meter is a direct mass measurement meter, since it also measures density directly, many processes and systems run off a volumetric measurement, and in that case Coriolis meters are also a natural fit. Since they again measure mass and density directly, it's a simple matter to divide these and provide a volumetric flow output directly from the meter, as well, with many additional benefits versus what you may use in a traditional volume measurement technology. As an example for some of those benefits of Coriolis, it's pretty well known that due to the unique nature of how it measures, there's no real moving parts in there, nothing to wear or tear or break down, so they're very, very low maintenance devices. Once you get them in and get them up and running, there's generally nothing you need to do to keep them going, no periodic maintenance or things like that. They'll just continue to hum and run forever. You know, we've seen several installations where customers have had a meter installed 20 years, maybe even 30 years, and it's still just ticking away. They haven't really had to do much with it. Along with that, it's pretty easy installation and startup. There's not a lot of tuning or anything like you need to do once you've got it out and you're installing it into the process. One other great benefit is there's no flow conditioning or straight run piping required. So this can make a huge deal if you're looking for something in a relatively small or confined space, or even if you're just looking to start up a new process. When you look at the amount of cost that goes into installing straight runs or flow conditioners just for flow measurement, it can add up pretty quickly. So having a device like a Coriolis meter, which you can, have a 90-degree elbow right before it, and you don't need to worry about it, is a good benefit as well. And finally, they're generally a very fluid independent and forgiving application fit. And by what I mean by that is, the device itself is capable of measuring both liquids and gases. It doesn't really care what's going through it, and so you don't have to do a lot of specialized selecting and picking out and making sure that the meter needs to go through an extensive, say, calibration process directly aimed at whatever fluid you're measuring. You're able to make the benefits of the measurement technology with a lot of forgiveness, and along with that becomes flow rate. So they can generally handle a very large flow rate for any particular size. So if you have some changes in your process, you're looking to up your capacity or your output, or you're wanting to run some smaller batches and things like that, generally a Coriolis meter can handle those wide ranges or turn down very well. So it's a key benefit of the technology. So besides just the overall benefits of Coriolis, I'd like to go and talk about some advanced capabilities, some things that may help you out both with what you're doing today or what you may be doing in the future. First, let's talk about two-phase flow, and particularly two-phase flow indication. This is always a big one. Two-phase flow is an issue that happens more than we'd expect and can really sort of wreak havoc on your process measurement. When you got lack of insight into that occurrence, it leads to fruitless hours of uncertainty, chasing ghosts in the process, trying to figure out what's going on. Maybe you don't really have confidence in your measurement at that point, so you're questioning the meter itself. So it can really cause some issues. Now, savvy users, people that have used Coriolis a long time, understand all the information coming out of it, they can generally track this phenomenon using detailed parameters from a Coriolis meter, looking at things like the output of the drive gain and what that's looking like, and pick-off voltage and things like that. But a lot of us just, don't have the time or energy to get into those sort of details and really understand what it means. So one of the things that we've done at Micromotion is that we've actually taken all that advanced analytics and understanding of how the meter behaves and the signals coming out of it, and we packaged it up and simplified because we don't want our users to have to be the experts and do a ton of data analysis to get to a conclusion if we can have the device give you the conclusion directly. So what we've done is we've introduced something called two-phase flow indication. This is available on the 5700 transmitter, and what it does is it packages up all that analysis and gives you clear, concise information about the state of your process, and lets you know if it's in, what we do is we notify you it's in one of three what we'd call regimes, which is single phase, you've got single phase flow, no entrained gas, or on the other side of things, if it's a gas flow, you don't have any entrained mist or liquid coming through, and at that point you can know you're getting an accurate and repeatable measurement out of the meter. Then there's a sort of a mid-tier indication, which is called moderate entrainment. So this means there is some sort of two-phase occurrence happening within the meter, and generally at this point you may be outside your base accuracy specification, but generally your measurements are still repeatable. And then the third level of indication is severe entrainment. So at this point, you've got some pretty severe gas entrainment, two-phase flow going on, and your measurement is likely neither inaccurate or repeatable at this point. There's something significant going on with your process, and if it's not expected, this isn't intentional, something you should probably take a look at because it's probably wreaking some havoc on your process. That notification is available through the display. It can be output through digital registers, so you can get that information out of the device in a variety of fashions. Another tool available is something called simple zero verification. So, another factor of flow measurement that can lead to a question of confidence in your measurement is whether the meter zero has been applied properly. This is a long-standing quandary and question in the mind of process technicians where, a good re-zero, if you operate under extreme situations, can provide an exacting baseline to tune into difficult measurements. However, a zero captured under less than ideal conditions, such as an imperfect valve seal or dramatically changing temperature, can introduce uncertainty in obtaining the best signal from the meter. So what you can do is you can look for some diagnostics out there, like this zero verification tool, which allows you to run it, and the meter will take a analysis of the process. And so you would stop it and block it in, and the meter is going to check for all these things that could result in the introduction of a bad zero and introduction of uncertainty into your measurement. So things like, is the valve completely closed, or is something leaking and you are getting some flow? Is there a rapidly changing temperature event happening at the time? All these things that we know from our experience can actually lead to an introduction of a bad zero. And then once it runs that, it will give you a recommendation as to, yes, the process conditions are stable, you could re-zero at this point if you want to, or no, something's going on, and what that event is, to make sure that you're not going ahead and proceeding and establishing an incorrect zero. One other thing to look for, and this ties in a lot to this whole theme of this webinar, of getting more information and more understanding of your process, is something like a historian or data logs. Again, for the same example, the 5700 transmitter actually has a real-time clock and some significant data storage capability on it, and it's logging data continuously all the time. Nothing you need to set up, it's all on board and it's all automatic, it's just doing it in the background. But what that allows you to do is to have this information to go and look deeper into what's going into your process, including all those variables we talked about are available from a Coriolis meter, to either, if you're looking to optimize, maybe tweak some things, get a greater understanding, or more importantly, it's a fantastic troubleshooting tool. So if something's gone wrong with your process and you don't have the information to understand what happened, a lot of times you're in that unfortunate spot of either crossing your fingers hoping nothing happens again, or now you're scrambling and try to install some sort of data logging capability to get more information. So if it does happen again, maybe at that point you'll be able to go understand what's happening, what's going on when you had an upset. So what this does is it gives you the ability to actually go back in time. So if some event happened and you want to look more into it and understand what the problem is, you can actually take the information off the Coriolis meter and go back and look at all those variables. They're stored at a 1 second increment for a rolling 30-day window, so a tremendous amount of resolution there to see what's going on. And then additionally, beyond that 30-day window, we actually store for up to 10 years. We take the 5-minute average of the data, so you can go back a significant amount of time if you need to. And then one final, what I call advanced Coriolis capability I'd like to mention is diagnostic, something like smart meter verification. So this is a very interesting tool. It gives you a lot more confidence in your meter and understanding as to the health of your meter. And what this is actually, when we manufacture the meters at our facility, we take a baseline or a fingerprint of the meter. And it's actually a fairly complicated analysis or way that we do that, and we establish that baseline. We actually, what you maybe would call, ping the meter with a variety of different tones and recognize the response back from the meter, which is both the mechanical response, i.e. the tubes and the state of the tubes, as well as an electrical response, so you can really qualify and understand and get an exacting impression of what the overall meter response and health of the meter as it's shipped right out of the factory is. So what that allows you to do is, once you have that meter and you're out using your process, you can initialize the smart meter verification routine, and it's going to ping those same tones back to the meter, look at that response, and by comparing that to the fingerprint, you get a wide variety of information that will let you know, if something's happened to your meter, make sure all your electronics are okay. And that comes across in a couple formats. The first and foremost, right up front is going to be a sort of green light, red light. So if you have somebody who just wants to go out, maybe they have some question about if the meter's functioning properly or something's happening, they can run that, get a green light, okay, we're good to go, nothing to worry about there. But then deeper, there's also some data behind it if someone in your organization wants to look into that and see what's going on, see some trending or anything like that. And again, this is all done at a push and a button. It's done inline. And while your process is running, it takes about 90 seconds. So you don't have to do anything special to your process to do it. You can set up a schedule to have it run in periodic intervals. So really a very good check of the health of the entire meter, both the mechanical and electrical components, just to give you that confidence that the meter is functioning properly and working the same way as it did the day it left our factory. So to tie it all together, before we go into the installation and integration best practices, you can really see now this combination of the vast, bandwidth and speed and ability to get information from something like an industrial Ethernet network. It just pairs naturally with that vast amount of information and the special capabilities and advanced diagnostics of a Coriolis meter, really allowing you to make the best of that measurement and get the most information and the most actionable information to keep your process running healthy and running at its optimum. So before we go into the last section, talking about some best practices for selecting and using Coriolis meters with an Ethernet network, we'll do our final poll of the webinar. So with all this talk, looking to really understand, what's the most exciting to you about the use of industrial Ethernet networks? There's a couple choices there to narrow in on, or of course, maybe you're someone who just still has some more concerns about it than excitement with what it can bring to your process. We'll just give it a couple more seconds. Look, we got almost the majority of respondents in. Okay, let's move forward and look at the results here. All right. We also got a good distribution here as well. So, the ability to get information out of the process to see remotely is certainly a huge advantage where, industrial Ethernet can open the door there. Simplification and cost saving certainly, and then being able to get more information from the devices. So it seems like, a pretty even split among what I would consider to be the top 3 benefits or advantages of using an industrial Ethernet installation. Looks like some of you still have more concerns than excitement. Certainly, understandable moving to something new. There's always some concerns. So hopefully the next section both helps those that are already excited and using it get some best practices for their installation or their Coriolis meter integration. But those of you that still have some more concerns about it, maybe there's some good information in here as well, some best practices to help ease that concern and give you some more or less hesitancy, I would say, and be able to utilize the benefits of an internet or an Ethernet network. So the first thing to look at is what I would call a typical plant Ethernet network. This is a pretty extensive one here, but this is a little diagram showing a lot of what I've seen when I've worked with users and when they've set up or they've started integrating their networks. This is sort of becoming the typical installation or architecture for that. So what I'm showing here is on the left you'll see what I call the business network. This is likely already established. This is all your computers, your printers, your email, all that good stuff that's in place within your business. And then on the right side would be the actual process network. So this is everything you're doing when you're establishing that out on the floor or out in the field, tying together all your devices. So a couple best practices here. Usually what I've seen and what I recommend is when you start getting to a larger amount of devices, tie them into sub-networks within that plant network there. And then usually the easiest way to manage all these devices, particularly with various control systems or PLCs, is each individual device is generally assigned its own IP number, IP address, a static IP. So for those of you that are not familiar with Ethernet networks, maybe more familiar with something like a field bus network, generally what I do is I think of this as when you assign each device its static IP, that's its address, it's sort of like its tag number. So when you're in the system, you'll often refer to each of these devices by their IP address. And one thing I want to take a moment to point out is that connection between the two. So for those of you having some concerns, maybe security concerns, maybe looking to do a new installation, one of the options is to actually have what's called an air gap and not connect the two networks at all. This is certainly, I guess, probably the most secure installation if you've got concerns about it, because then your process network is completely isolated from any other networks, the outside world and things like that. So you really have no real concerns about information getting out of it where you don't want it to go. However, as you grow and you're looking to recognize the benefits of this remote monitoring, having more information available to other people in your business, you will likely want to connect the two. So it's highly recommended you do that with a limited connection, maybe one single point or two single points where the information passes through. And of course, at that point, you're going to want to use something like a secure VPN and make sure that's well controlled and segregated there to make sure you understand where the traffic is flowing. I certainly would never recommend having multiple open connections between your process network and your business network. Use some best practices, make the most of it, and make sure you have a good understanding of what that traffic looks like. So in terms of selecting Coriolis meters for your network and what's the best way to go about that, there's a couple of things you can look for. I personally recommend when you select a Coriolis meter, look for an option with dual ports, dual Ethernet ports on the device. And the reason for this is it actually opens up a lot of options in terms of both your installation topologies as well as giving you additional information or additional ways to connect to the device. I'll actually go into on the next two slides a couple of these different topologies and the benefits, pros and cons of each. But another thing to look for besides that, to have those dual Ethernet ports, is some meters now are available, like the 5700, with an extensive hazardous area approval, which can even be used in a Class 1 Division 1 area with the use of Ethernet. So now you can have a common approach if you're in one of those industries where you have various hazardous areas. There are Internet or Ethernet devices out there, Coriolis meters, that you can use in those areas and get the benefits of Ethernet and a standard approach. So I think that's pretty exciting to be able to have something that can go in all areas of your plant or facility. So talking a little bit about the various installation options and how you can make the best of those. So really the simplest installation is what would be called a direct connection or a star type of topology, which is you'll have a connection from your PLC or your system to a switch, and then individual Ethernet runs out to the devices. So if you're doing a small installation and there's a switch nearby, this is really the simplest way to do it. And it does give you the benefit, again, if you have that dual port device, you can hook into that other port if you want to with a laptop or something like that, if you need to interact with the device, although a lot of times that's not necessary because you are, again, getting all that information back over the network. So another couple kinds of topologies you can use, and this is where it gets interesting in terms of space and cost savings, is something called a ring or a daisy chain. So you can see those there. So in this case, you're actually making a connection to a meter and then using that second port to make a connection directly to the next meter, et cetera, down the line. And for larger installations, this can really be a significant cost reduction, both in installing that cable and having switches out. It really enables you to make the most of your installation at a minimal cost. Now, I will point out here, I would recommend, if you utilize this type of installation, I would definitely recommend you go ahead and take that last port off of the last device and bring that on back to your switch, back into your system, and complete the ring. Go with the ring type installation. And the reason for this is when your devices on that loop can support DLR, which is device level ring technology, what happens is if one of those devices goes down or the power is shut off on it, the traffic actually reroutes back around the sides of the ring, and you still maintain communication at that point. So certainly worth connecting that ring when you go for this sort of installation. Another thing to look for is what additional system I/O options are available with your Coriolis meter. So some Coriolis transmitters also contain an additional configurable output on it, and this is really exciting to think about the different ways this can be used in your particular installation, and it opens up some applications as well as those that have maybe some concerns about Ethernet networks and installations. This can provide some redundancy to it, and what I mean by that is that additional output can actually be configured as, say, a milliamp output. So if you have a current installation or system that uses an analog signal, what you can do now is you can continue to use that same analog signal in the way you're used to, but now you can start adding on an Ethernet network to maybe get some additional information or things like that. Or if you're switching over to the Ethernet network, you can maintain that other signal to your legacy system just as a backup. Make sure you've got something to compare against. And so this can really help that confidence level if you want to make sure that you're getting a network set up and the correct information out of it. Some other things you could do with an output like that, actually, you could use a discrete. You could change it to a discrete output, so now you can trigger valves directly from the device. Transmitters like the 5700 Ethernet version are available with integrated batch control software, so you can actually do batching directly from the device itself, and you can trigger that valve then with that discrete output, so you can really reduce some equipment and consolidate it down into the device itself. You can use it as a discrete input, so if you have a totalizer reset system in place, you don't want to do totalizer resets through the Ethernet system, or you've got sort of an older system, even if it's just a push button type of system you use to reset your totalizers in your meter, you can use that as a discrete input to do it that way. And finally, a lot of those that people are looking to expand this out into the field or oil and gas industries, we know proving applications basically run off a frequency output. That's what you need to do to prove your meter. So in this case, you can take advantage of Ethernet in your installation, but still have a frequency output you can use to prove your meter periodically as required. So a couple notes on the actual connection of the Ethernet cables themselves and some best practices here. The most common installations you'll see, a lot of people will just use a typical RJ45 like you're used to using in your home or office. Certainly no problems with that. A lot of times they're just field terminated out on site, easy way to install and get up and running and make the most of your installation. But I would note that it's worth maybe looking into, there are some more ruggedized type of connectors out there. You can see an example on the bottom right of the screen. So these are more made for those industrial type environments. They sort of open up like in that picture there, and you can terminate your cable that way, and it does provide that more rugged industrial type connection to your devices. So one best practice here is make sure when you're selecting your flow meter and transmitter that was designed with space available on those ports to be able to make the use of those larger industrial type connections. Another alternate connection option available is an M12. A lot of times these are known as quick connect couplings. So you can actually get devices with these pre-installed in them for you. So a lot of times these are beneficial if you're doing some skid design or something like that, or something modular where you want to be able to quickly connect and disconnect instruments and systems. So these are available, but I will make a note. As I mentioned earlier, transmitters like the 5700 are capable of being installed in a full Class 1 Div 1 area or Zone 1 area with the proper installation methods. These type of quick connects, these M12s, are generally not suitable for those installations. Generally, they're only for Class 1 Div 2. So just a little best practice or word of warning out there if you're looking to go with these type of connections. And then one final thing I'd like to point out is look for some additional capabilities in your meter. One of the interesting ones that I personally like a lot is a web server. So making the most of these Ethernet networks means now something like a web server can actually be developed and stored directly on the device so you can directly connect to it. So any computer on your network with a web browser, what you can do is you can go directly to that IP address of the device. Like we talked earlier, most times these have static IPs, and you can log in through a secure connection and get information directly from the device. So for example, with that 5700 transmitter, you can log in, you can see your process variables, but generally you'll be doing that through your PLC or your system. But you can do additional things, like you can do a full configuration of the meter. You don't need special tools or equipment. It's all there right on board the transmitter itself on the web server, as well as access tools like that smart meter verification we talked about earlier, or the zero verification wizard. You can all do that directly from it. And plus the big thing is that historian. We talked about how the transmitter actually logs historical data and information about your process. Now you can dial into this web server and you can pull it directly off of that. You don't need to go out to the field to the device. The benefits of Ethernet means you can get that extensive information off very quickly and don't have to worry about a large file transfer or something like that. Additionally, this can even open up the way if you have a secure VPN network within your process plant that would allow you to dial in or access it from mobile devices. Something like a web server is easily accessible through those, enabling some sort of remote worker type of deals, or being able to get additional information from the device without actually having to crack the can or open it up to hook up to it. You can just connect to it right through that web server in your mobile device. So pretty exciting stuff on that end. So, in summary, there's a lot of benefit to looking at an Ethernet-based industrial network, see if it's something that can bring some advantages to you and bring some additional process insight, and in terms of both installation costs as well as being prepared to move forward in that extensive information you can get from it, which couples naturally with Coriolis meters and that vast amount of information and insight you can get off of those, particularly including those advanced capabilities and diagnostics. And when you're looking to select Coriolis meters, specific functionalities like having dual redundant Ethernet ports plus a configurable output, something that can be used in all hazardous areas, can really help you make the most of your equipment and get the most out of your process. So at this point, I'll go ahead and throw it over to Allison, and we'll go through some of the questions that have been submitted.
Thanks so much, Jason, for all this great information. As Jason just mentioned, we're now going to open it up for some questions. So please use the Q&A chat window to ask the questions. And Jason, I've already got you queued up for a bunch of them here, so I'll let Jason get started while everyone else starts thinking of their questions and getting them in.
Okay. All right, well, we've got some good questions. Thank you, everybody. We'll start going through these here. If I don't have the answer, we'll make sure to get it out to everybody afterwards. I can go research it. We got a ton of experts back here that help me out, so we'll make sure to get all the questions answered at some point. The first one is, what about DHCP technology? Is that possible or useful for industrial networks? Okay, yeah, that's a good one. For those of you not familiar, DHCP, I can never remember what it stands for, but basically it's the ability of a system to assign IP addresses to a device. So it can be beneficial in some cases. A lot of times I see people actually generally don't use it because unless you're pretty savvy and your system is set up in such a way, you generally don't want to be automatically assigning IP addresses to devices. Most people take that approach where they have one set fixed static IP per device, but it's certainly available if that's something you use. I know, for example, the 5700 we've been talking about does have that capability in it, so certainly there are devices out there that can use that. Okay, let's see what we got. We got a question about how accurate is the temperature measurement with these devices. That's a good one. So generally, our rule of thumb is the temperature measurement coming from a Coriolis meter is about plus or minus 1 degree. And the reason being for that is it's not a thermal well type of calibratable or wetted temperature measurement. It's actually a temperature measurement used from the skin of the tubes within the Coriolis meter where the fluid flows through. So it's not the most accurate measurement in the world, but plus or minus 1 degree is fairly good, and a lot of times it can replace some other temperature measurements if you're looking to use that at that particular point in your process. Got a question here about how does a Coriolis meter work? We can go into that one for quite a bit. In the interest of time, what I'll do is I'll go ahead and send you a link after we're done with this. We've actually got a tutorial. It's something you can step through online. They'll give you some background information on how Coriolis meters work. We'll address that one that way. And if you have any other questions, we can work through those as well. Okay, we've got a question about what are the limitations for length of Ethernet cable runs. Okay, good question. So the standard for both 10 base T and 100 base TX basically says devices have a 100 meter limitation to the length of cable run between them. So, we've certainly tested our devices and we know it meets that standard as well. So when you're planning out installations, that's a good rule of thumb to go by, 100 meters between the applicable devices. Is the web browser functionality locked out for custody transfer meters? So I would say the better way to address that is not just the web browser functionality, but the overall functionality of the meter. So, for example, on the 5700, it does have a switch on it that puts it into it's a physical switch that puts it into read-only mode. So when that switch is engaged, any sort of access, be it through the system, through the web browser, through the display, is all in a read-only type of approach, similar to what you would see in like a weights and measures approved device. That switch can be locked behind the display using a wire tie and seal, something like that. So generally the same approach you would see with other devices with digital communication like Modbus, that same type of physical security and control for it. Thank you. This isn't a question, but one of our attendees threw out that DHCP. I can't remember what it stands for. It stands for Dynamic Host Configuration Protocol. So thank you very much for throwing that out. I really appreciate it. We got a question about is the logon going to be username based or one general password? I assume that means for web browsers. So generally when you're looking for a device with a web browser, I'd recommend you making sure it has some type of login type security. I am not familiar of any that in the Coriolis meter space that have a user-based security, what I call, Chuck has these permissions, where George has these permissions. But a good approach is to look for one that generally has a admin or an operator type of group of permissions. So you can have certain people that can log in that operator role, or other people that can log in with the admin role to control access at that point. Got a question here. Sorry, one of these questions, I'm not quite sure what it means. I'll skip over that one and we'll get back in touch with you. If you submitted a question and haven't had an answer to that yet, we'll be sure to get back in touch with you for that. I need a little bit more information. We can have a discussion about exactly what you're asking for. It looks like we've got one more. I've heard about an EDS file. What's that, and how does it help with instrument integration? Okay, yeah, that's a good one. So an EDS file is called an electronic data sheet. And for those of you that may be more familiar with field bus type installations or HART or things like that, you can think of the EDS as equivalent of a DD. So it's what tells the system, hey, here's all the information that's coming out of this device and what it is. So it's got a couple interesting options or things you can open up with that. One example I'll point out for sure is if you're using something like a Rockwell PLC, particularly version 20 or later, they did some great advancements in version 20 or later. Any of you out there looking for maybe get into the PLC or looking to upgrade, oh man, if you go to 20 or higher, you get a ton of improvements, particularly around this EDS. And what that does is it allows any device out there that's Ethernet capable, if they have an EDS file, it greatly simplifies the integration. It can generate what's called an AOP or an add-on profile. So when you go to integrate your device, it's really streamlined or simple. You can fly right through it and get that thing up and running. So that's sort of the best use of an EDS file I've seen. We have other devices like Schneider Electric with their Unity platform. They can take use of that EDS file as well. Again, it's basically a DD. Lets the system know how to use the information coming out of the device. We've got a question here, and we're almost out of time, but it looks like we got one more. Oh, we got two more here. We have to remove our meter every year for calibration verification. Is EPA required? Does the self-test you talked about meet that? Oh, it looks like it's cut off. I'm guessing say meet that requirement, or would I still have to remove them and send them in? That is a great question. Wow, I feel like you're a plant or something, but that's a fantastic one. That smart meter verification we talked about is actually approved by the EPA. You can come to our website, or we can get you in touch with some people afterwards to look at the certificates and all that good stuff. But actually, the EPA does recognize smart meter verification, and I believe that is the only Coriolis meter health diagnostic out there approved by the EPA that you can actually use to extend the periods between your calibration time. So that could be a great help to you if that's something you're looking for. And then we got one more question. This isn't really about Ethernet, but about an application. We're about to test a Coriolis meter to measure flow of coarse carbon slurry. Do you have experience on similar applications? Me personally, I've not used a meter on coarse carbon slurry, but I've had experience with slurries of various types. Anything from cement to there's actually a particular application where if the slurry reaches a certain temperature, it actually hardens up in the meter. So we've had experience with all sorts of things like that. Generally, Coriolis is a good technology for something like a slurry. The one thing I would recommend, going back to the smart meter verification, I would definitely take a look at that if you're running a slurry application, because that smart meter verification can detect things like erosion on those tubes. So if you're running something that's particularly abrasive, that would be able to tell you if there's any sort of damage happening to your meter in that application. Okay, I think that's all I know the answers to, or I understand what they're asking, and we're about out of time. So thank you all for joining. We'll come back with some answers to some of the remaining questions, or be in contact with those of you that submitted if you'd wish to talk a little bit deeper. So thank you for attending.
Perfect. Thanks again, Jason. And as Jason mentioned, if we have not answered your questions, Jason will be following up all of those that he does need to reach out to some additional research on. And if you think of additional questions in the meanwhile, don't hesitate to use that button on the bottom there to reach out to us, or to directly reach out to Jason, and we'll be sure to get back to you. Thank you, everyone, for joining us today and for all these great questions. As a reminder, we will be sending out a link to the recording via email tomorrow, along with links to all of the resources that you're currently seeing in your webinar area. On behalf of our guest, Jason Leslie, as well as everyone here at Emerson Micromotion, we thank you again for joining us and taking the time to view the webinar, and we hope that you have a great day. Thank you.